Hey guys, this is Alan with Bothell STEM Coach, and today we're doing another AP Physics 1 free response question. And this one is energy focused. So I encourage you to pause the video, attempt to do the problem on your own, and then come back after you've attempted the problem. A spring that can be assumed to be ideal hangs from a stand as shown above. You wish to determine experimentally the spring constant of the spring. What additionally commonly available equipment would you need? I would need, so here I would just simply use F equals Kx, or K delta X, and I would apply different forces downward in different measurements of the displacement. So how I would apply different forces is known masses of known objects with known mass of different masses, right? Known masses of objects in a meter stick. So if I know the mass of an object, I can compute m, right? And then I want to compute the displacement. So basically I would apply a weight, see how much the spring stretched, measure it, apply a different weight, see how much the spring stretched, measure it, etc. And I would plot F on the y-axis, delta x on this axis, and I should see a pretty linear relationship between delta x and the force applied, where F is equal to mg, the mass of the objects that I'm hanging off to it, and then the slope would equal k. Because if I do this as a y equals x, this is y equals mx, the slope would be so I plot this on the x-axis, this on the y-axis, the slope would just be k. Suppose a spring is now used in a spring scale that is limited to a maximum value of 25 newtons, but you would like to weigh an object of mass m that weighs more than 25 newtons. You must use commonly available equipment in the spring scale to determine the weight of an object without breaking the scale. Okay. If you want, so if I wanted to weigh an object to figure out like the mass of it, and if I break it, like if I apply more than 25 newtons, it would break. One thing you could do is you could put it on an incline. This is like a trick, because this redirects the force of gravity a little bit. So if I have a spring scale just, and I put the mass here. So rather than hang it straight up down, right? Say it weighed like a whole bunch, whatever its weight is. Now the weight is sort of against the spring is directed in a different direction, so it doesn't like counteract. So let's do the free body diagram. Let me just kind of show you how this would work. Let me switch to red. I would have the weight of the object. I would have the force of the spring scale, and I would like make it nice and coded so there's no real no friction, right? No, I'd have a normal force. So I don't really care about the normal force if there's no friction. I only care about the force in the spring direction. And so the force in the spring force would have to equal the component of weight in the same direction along this axis, right? So it would be, this is some angle, it would be the weight of the object times sine theta. Okay, so the weight I could calculate from the spring force divided by sine theta. The sine theta is what the scale would read. Okay, and theta could be known because I could measure this angle specifically. So this is how I would compute the weight of an object. I would say, well, the spring scale only says like 10 newtons. I would divide by sine theta, and that would be the estimated weight of the object in total. And so I can basically, by inclining it, it's like less force. It's kind of like if you got to hold up a whole block straight up, it feels heavy. But if I do it on an incline and I'm holding it up and the incline's pretty shallow, gravity's not as, the portion of gravity I have to fight against is not as much. So that's what you would do for there. Okay, hope you guys found that helpful. I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.